Hey class, Mr. Houston here, back with another exciting episode of Geometry Notes. Today we are moving into Chapter 6, which is all about similarity, and today we're going to talk about Chapter 6, Lesson 1, which is using similar polygons. Okay, the only vocabulary word that maybe you haven't encountered is called scale factor, and a scale factor is a ratio of lengths of two corresponding sides, and we will talk about how to find a scale factor in this lesson. So the very first thing we're going to talk about and look at, before we get to example 1, is just what we mean by similar. Similar means they have the same shape, but not the same size. So we still have corresponding angles, and therefore we still have corresponding sides, but our corresponding sides are not going to be equal. They are going to be proportional, meaning, if we put them in a fraction, they would all simplify down to the exact same thing. All of the angles will still be congruent. If you notice here, we still have all the congruent signs in between. And then the sides, again, will be in proportion. Their ratios will be the same. Okay, so let's take a look at example 1. All right, so a couple of different things going on here. Example 1, we are being told this little symbol right here means similar. So triangle RST is similar to triangle XYZ. The first thing I want us to do is to list all pairs of congruent angles. Basically, and this is the way I like to teach it, is that the angles, as they're written up here, are congruent to the angles in the same order up here. So if I was to write that for letter A, I would say angle R is congruent to angle X. Angle S is congruent to angle Y, and angle T is congruent to angle Z. They just match up, whichever position they're in on this one, they're also going to be over here. They're not going to mix them up in any way, shape, or form. That's the way similarity statements work. Okay. Next, for part B, says to check the similarity, or check the ratios of corresponding sides. Okay, so basically we are just going to go through, and I'm going to pick a side. So I'm going to start, and it's the same thing. I can say RS, so RS is 20, and it needs to be compared to XY. XY is 12. So when I do 20 over 12, if I simplify those, I know 4 goes into both of them. I get 5 over 3. Okay, then we'll move on to the next one. Maybe we'll do ST. So ST is 30. ST would be the same thing as YZ, 30 over 18. I know 6 goes into both of them. That's, again, going to give me 5 over 3. And last but not least, we will do TR. TR is 25. ZX is 15. 5 goes into both of them. We get 5 over 3. So by these all being the same, we know that this similarity statement is true. We also know that this is our scale factor. Okay. Depending on how we talk about it, this bigger one is 5/3 the size of the smaller one. Okay, but this ratio that we come up with, that is our scale factor. Scale factor can be used for a number of different things. For example 2, we're not really using the scale factor. We want to find the scale factor. So what we're going to do is we are going to just do the proportional statements like we did in example 1. So I like to look at the angle measures. When they don't tell us the sides, I'm going to look at angle measures. And when I look at angle measures, I'm going to look at the same thing. So I'm going to go from this one arc to the right angle. So this one arc to the right angle. So that's going to be 16 over 20. Simplify that down. 4 goes into both. We get 4/5. And then I just kind of work my way around. JH is 12. WX is 15. 3 goes into both of those, giving me 4/5 again. HG is 24. XY is 30. 6 goes into both of those, 4/5. And last but not least, we get 20 over 25, which again will simplify down to 4/5. Okay, so we have determined that they are similar. We've determined that our scale factor is 4/5. Okay, hopefully this is making sense. Nothing too complicated there, but just wanted to make sure we all understand what exactly that is. Okay, let's use the scale factor. Okay, when we know a scale factor, or basically if we know something is similar, we know that their sides are in proportional, or they're proportional. So that means we can set up a proportion to determine anything that is missing. So in this case, we are missing the value of x right here, which corresponds to this side here. So my first part is going to say x over 20. Their proportion is going to be equal to, and you can pick any of the two remaining sides. Just make sure that we're writing them the same way. So x comes from DEF, so I'm going to say 9, and then I need to find the corresponding side in MNP, which is 12. Okay, just a brief refresher on solving proportions. You're going to do two steps. You are going to multiply, cross multiply, and then you are going to divide. So we're going to get 12x equal to 9 times 2 is 18, and then you tack the 0 on. Then after you cross multiply, then you're going to divide. In this case, 12 goes into 18 one time. You're left with 6. 12 goes into 65 times. So the missing value here is x equals 15. Okay. So again, similar figures are proportional. That's why we can set up a proportion and solve. Flip your notes over. All right, get to add more to this theorem postulate page. Okay, theorem 6.1, perimeters of similar polygons. If two polygons are similar, then the ratios of their perimeters is equal to the ratio of their corresponding side lengths. So basically, once you find that scale factor number, their perimeters are also in that same scale factor. So if we get that 5/4 again, their perimeters would be the same. You could simply use that to set up a proportion to determine the perimeter of a given figure, which is exactly what we are going to do right here. Okay, all right, so a town is building a new swimming pool. An Olympic pool is rectangular with lengths 50 meters and 25 meters. The new pool will be similar in shape, but only 40 meters long. Okay, so the length is 50 and width is 25. The new one, length is 40. So the first thing we need to do is find the scale factor. So since I know the length of this one and the length of the old one, I'm going to use that to determine the scale factor. Most times scale factor is always new over old. So the new one is 40. The old is 50. We then will simplify that down. Anything that ends in zeros, you can cross them off. So my scale factor is 4/5. Okay. Now we are going to use that to find the perimeter of the new pool. The perimeter of the Olympic pool is easy to find. We picture it over here. Okay, if that's 25, this is 25. If that's 50, this is 50. So the perimeter of the old pool is 150. Remember, perimeter is just to add up all the sides. All right. We don't know what the perimeter of the new pool is, but we know the scale factor is 4/5. So we're going to do our cross multiplication. We're going to get 5x equal to 600. And then we're going to divide by 5. X in this case is going to be equal to 120. In this case, we need to be pretty specific. It says meters in our problem, and so our perimeter is going to be 120 meters for the new pool. Okay? So a lot of different things we can use with scale factors. That's kind of the thing we're getting at here with similar figures, is using a scale factor to find anything that might be missing. All right, so in this case, we are trying to find this length right here. Okay, So what we want to do is, again, everything's proportional in this case. So we are going to use the length of TR and XZ. So TR is 12. XZ is 16. We don't know what PS is. We're going to call that our X. But we know that its match is 20. And then we're going to do our cross multiplication and dividing. Okay? So however, you can always simplify. Like I could simplify this fraction first if I wanted to and then multiply. Whatever you choose to do, it's up to you. I know 16 times x is 16x. 2 times 12 is 24. Therefore, I just add a 0 on the end. Maybe. Oop. Technical difficulties. There we go. Then we divide by 16 on both sides. And we will find x, in this case 16 goes into 24 once. That leaves me 8. 16 into 80 is 5. We are going to find that this length right here, PS, is going to be equal to 15. Okay? So that's kind of the beginnings of similar figures. Hopefully you understand a little bit about scale factors. If you have any questions, bring them with you to class, and we will see you then.